For decades, the automotive industry has been trapped in a debate that refused to die. Are large displacement V8 engines still relevant in a world being reshaped by turbocharged V6s? Hybrid powertrains and full electrification are naturally aspirated big block engines, nothing more than outdated, inefficient relics from a different era. Ford answered that question with the 7.3-liter V8. And the answer was not delivered through advertising campaigns or cherry-picked dyno results. It was delivered through real-world performance, proven durability, and an engineering philosophy built around the people who actually use these trucks every single day. Ford did not simply build another V8. They built an engine that makes a statement, one that redefines what a modern large displacement gasoline engine should look like, feel like, and last like. Over the past decade, automakers made a collective push towards smaller, turbocharged engines. On paper, that direction seemed logical. Better fuel economy numbers, reduced emissions, and higher peak power output per liter of displacement. But in practice, especially in heavy-duty work applications, commercial fleets, recreational vehicles, and serious towing situations, the real-world results told a very different story. Mechanics and engineers started seeing a consistent pattern: turbo heat stress, complex cooling systems, long-term reliability concerns, and repair bills arriving well after the warranty expired. One veteran powertrain engineer put it plainly, saying turbocharged engines are impressive, but optimized for laboratory test cycles, not for 300,000 miles of hard towing and hauling. That gap between what the numbers promised and what the worksite demanded is precisely where Ford's 7.3-liter V8 stepped in. Ford's 7.3-liter V8, known internally as the Godzilla, was never conceived as a horsepower headline chaser. Ford's engineering team built it around three core priorities. First, massive low-end torque. Second, extreme long-term durability. Third, mechanical simplicity. According to Ford's own powertrain team, the objective was to produce an engine capable of outlasting the truck it was installed inside. The engineers were not designing for the original buyer. They were designing for the third and fourth owner. That mentality alone separates the 7.3 from nearly every other engine in today's market, and it shows in every mile these trucks put down. At first glance, the 7.3-liter V8 appears deliberately old school, and that appearance is entirely intentional. Pushrod, overhead valve architecture, large bore and stroke dimensions, a naturally aspirated cast iron block. But beneath that familiar layout sits a thoroughly modern piece of engineering. The development team applied advanced cylinder head airflow modeling, contemporary combustion chamber design, variable cam timing, precision fuel injection systems, and refined oiling and cooling pathways throughout. One engine design consultant described it by saying Ford used modern simulation tools to perfect a classic layout, and that combination is exactly why it works as well as it does. The biggest mistake in modern engine comparisons is fixating on peak horsepower numbers. Truck owners and fleet operators do not care about peak power at redline. They care about torque at low RPM. And that is where the 7.3-liter V8 establishes its dominance. Rather than waiting for a turbocharger to spool up or depending on high RPM performance, the 7.3 delivers immediate throttle response, strong torque just above idle, and linear power delivery with zero lag. That characteristic makes an enormous real-world difference when pulling heavy trailers, hauling construction equipment, crawling through off-road terrain, or climbing long grades under a full load. A fleet manager running Super Duty trucks explained it by saying his drivers do not read spec sheets. They need the truck to move the moment it is loaded, and the 7.3 does that every single time. If capability started this conversation, reliability is what ended it permanently. Across the industry, mechanics consistently report the same experience with the 7.3: fewer failure points, lower operating temperatures, and less cumulative stress on internal components. Unlike turbocharged alternatives, the 7.3 does not depend on boost pressure, intercoolers, high-pressure turbo bearings, or complex heat cycles driven by modern emission systems. One independent engine rebuilder made a remark that says everything. He called it one of the few modern engines he sees that is actually built to be rebuilt. That observation alone explains why the 7.3-liter has earned legendary status among working truck owners so quickly. Ford engineered the 7.3 specifically for hard use. Extended idle times, maximum load towing, extreme temperature swings, and dirty operating environments were all factored into the design from day one. Construction crews, utility companies, and RV owners have all reached the same conclusion. The engine simply keeps running when others begin showing strain. A commercial fleet engineer summarized it by stating that downtime costs far more than fuel ever will, and the 7.3 saves money where it matters most. In a market where engines grow increasingly complicated with every model year, Ford made a deliberate and contrarian choice. The 7.3-liter V8 proves that simplicity is not a step backward. It is a strategic advantage. Fewer moving parts mean fewer failure points, easier diagnostics, faster repairs, and longer service intervals. That matters enormously for rural operators, remote job sites, emergency services, and any application where reaching a dealer is not realistic. One heavy-duty mechanic put it directly by saying that when something does go wrong with the 7.3, he can actually fix it without disassembling half the engine bay. The success of the 7.3 forced a meaningful shift in how Ford approaches powertrain strategy. Rather than abandoning large displacement engines, Ford committed to application-specific engineering, turbocharged engines where fuel efficiency carries the most weight, and large displacement, naturally aspirated engines where durability matters more. That balanced approach explains why Ford now dominates across multiple market segments simultaneously. One powertrain analyst noted that the 7.3 proved there is still enormous demand for engines that are straightforward and honest in what they deliver. The aftermarket community confirmed what work sites already knew. Engine builders and performance shops embraced the 7.3 for restomod projects, drag builds, off-road applications, and marine use. The reasoning is consistent across every builder: strong block architecture, excellent airflow potential, and high torque capacity without requiring forced induction. One performance builder called it the best modern V8 foundation seen in years. And that kind of enthusiasm from serious builders does not happen by accident. Nobody claims the 7.3 leads the industry in fuel efficiency. But experts consistently raise a point rarely found in manufacturer brochures. Under real towing loads, naturally aspirated engines like the 7.3 frequently match or outperform smaller turbocharged engines in actual consumption figures. No boost enrichment requirements, no turbo heat penalties, and lower average RPM operation under load all contribute to that outcome. An automotive efficiency researcher explained that when hauling heavy loads consistently, naturally aspirated engines tend to operate closer to their optimal efficiency range than turbocharged alternatives. Ford's 7.3-liter V8 did not just earn loyal customers. It forced competitors to reassess their own strategies. The uncomfortable reality now facing rivals is this: smaller does not always mean better. Complexity does not guarantee longevity. Buyers across America still place durability above engineering novelty. One former OM engineer put it directly by saying Ford reminded the entire industry that foundational engineering principles still matter more than trend chasing. The 7.3-liter V8 is not a rejection of the future. It is a clarification of purpose. Heavy-duty applications will continue demanding high torque output, mechanical robustness, and predictable performance under extreme conditions. The 7.3 exists to serve exactly those needs without compromise. It did not end the debate with slogans or marketing campaigns. It ended it with miles logged, loads hauled, and engines still running strong years down the road. In today's automotive world, that kind of honesty turns out to be the most powerful engineering statement of all.